Hi and welcome to the part 4 of this Docker training module. So in the last video we understood about a lot of Docker concepts where we saw how we can create containers using limited resources. Then we looked at a lot of different commands like docker inspect and docker kill. Then we saw port forwarding and how to create custom images, how to send it to a Docker Hub account public repository, how to pull an image from the public repository, then how we can create a remote registry and how we can push and pull our custom images. So we saw all these different concepts in the last video. In this video we are going to continue further and dig a little deeper into Docker. So the first concept that we are going to understand in this video is what is Dockerfile and how to create a Dockerfile. So before understanding anything about Dockerfile, the first question is why is Dockerfile required? So in the last video you would have noticed that we created a custom image by making certain modifications in the container. Like for example, first we installed Apache and then we created our test folder and then we created a custom image out of that container and then we kind of pushed it to a remote repository and pulled it later. But here the point is that we had to make the change in the container and then after that we created our custom image. But when it comes to Dockerfile, we can write all those instructions directly into our Dockerfile, which means that once we build our custom image from the Dockerfile and later when we will create the container from the custom image, then automatically all the instructions would have got executed in the container, which means that for example if you had installing Apache into the container as an instruction in your Dockerfile, then when the container is created from the custom image, then Apache would have got installed. So this is just an example I'm giving. Similarly, if you had any particular folder to be created as part of your instruction or any particular script had to be run, then all such instructions will actually get executed when the container is created from that particular custom image. So this is why Dockerfile is extremely helpful when it comes to creating containers with specific configuration. And we can have a specific configuration by writing multiple instructions in our Dockerfile, and after that we can create our custom image, and from that custom image we can create our containers. So currently I am logged into my EC2 instance in the AWS account. So first we will create a test folder, and after that inside the test folder we will create our Dockerfile. So first let us create the test folder. So we will give the command mkdir and then we will give the test folder name. So we can say test docker, and now we will get into this folder. So now let us create the Dockerfile. So we'll give vi and the name of the Dockerfile should be Dockerfile and D in capital. So now we are inside the Dockerfile. So here I have copy pasted the instructions of the Dockerfile. So instead of writing it down, I thought of directly copy pasting the instructions and just explaining you what the different instructions mean. So first thing first, the instructions that you could see in the blue color are basically the comments, which means that when the Dockerfile is getting executed, those comments will be completely ignored and it won't be taken into consideration. Only the instructions which are right other than the blue color, those will be executed. So usually when you create a Dockerfile, it is not required to write these comments, but yes, for understanding purpose, for better explanation of the instructions in the Dockerfile, you can always write such comments, but this is for training purpose only. So I have written all these comments for training purpose. So if you remember in the part 2 video, we saw that whenever we pull any particular image and then if we check the path where lib docker overlay to, right, when we execute the command ls in this particular path, then we will see the list of instructions that are stored for all the images. And whenever you pull any new image, then a new set of instructions will be written in that particular path. Similarly, when you create a Dockerfile and later when you create a custom image from that Dockerfile, then automatically those instructions will be written in that particular path, so that later when a container is created from that custom image, then automatically those instructions will be executed in the container. So this is how it works. Now let us try to understand each and every instruction which is given in this Dockerfile. So the first instruction, as you can see, is from Ubuntu, which means that if you use this particular instruction, then automatically that particular image will be pulled from the public repository. Similarly, if you have, for example, multiple images to be pulled in your Dockerfile, then automatically you can give multiple set of instructions with the from keyword. Now the second argument in this Dockerfile is argument Debian frontend non-interactive. So this is just an argument which we are passing in our Dockerfile, which ensures that there is no interaction when any kind of upgrade or installation is going on when the container is getting created. For example, if you remember, when we were installing the Apache 2 service in our container, it asked for certain questions like, for example, the geographical area and also the time zone. So if you want to avoid that when your container is getting created or the image is getting built, then you can simply pass this argument Debian frontend non-interactive. So this is just to basically let you know that you can pass such arguments in your Dockerfile. Now let us move on to the next instruction, which is run apt get update. So this is basically when your container is getting created, we always executed the apt update command just to update all the softwares. So now as you could imagine that when the container is getting created, automatically the apt update command would have got executed. The next command is installing the Apache 2 service. So if you remember, we installed the Apache 2 service by using the command apt install Apache 2 and -y. API. So same instruction we are passing in this Docker file. So of course, when the container is getting created, this command will also get executed in the container and Apache 2 service will be installed. And the next instruction is we are passing all the files in the current directory from which we are executing the command to create the container. So all the files in that directory will be copied to the var www html folder. So such instructions also we can write in our Docker file. For example, if we want to move any folder or copy any specific file from a folder to another folder inside the container, then all such instructions we can write. So this is just to give an example that all the files in the current directory will automatically get copied into the path that is mentioned, which is var www html. So here the current directory is nothing but the path in your Docker host, and var www html is nothing but the path inside the container. So remember that the first path is of your Docker host and the second path is which is inside your container. So now let us move on to the next instruction, which is entry point apache ctl -d foreground. This particular command has more to do with Apache itself, so we will not go into what this command actually does, but what we can take from this particular command is that the keyword entry point, what it does is whenever a container is getting created and if you have given any particular command after the entry point keyword, it will ensure that the command is executed after the creation of the container. But we have another keyword which is called cmd, and using the cmd command we can again execute any command inside the container. So the question is, what is the difference between a cmd command and the entry point command? Basically, if you see, both the commands or both the keywords are actually doing the same thing, which is to execute a particular command. But what is the difference? So here is an article which clearly explains the difference between the cmd and the entry point keyword, which I found in Google. So let us first see how cmd keyword basically works. So if you come down, you can see that they have created this particular Docker file using these instructions. So as you can see that these are very simple instructions. So first they are basically calling the Ubuntu image, and then they are running the apt update command, and finally they are executing the cmd keyword with echo and hello world. So basically when the container will be created, at that time hello world will be echoed in the output. So which means that in this particular keyword, this is the command echo and this is the argument. So now if we move forward, then as you can see here, then when they executed the command docker run and when they are trying to create a particular container, then as you can see that hello world is printed as the output, and this is coming because of this particular keyword command cmd and then echo and hello world. So basically when the container got created, automatically this echo command got executed and hello world got printed. But when you pass a particular argument in the docker run command, then what happens? So if you come down, then as you can see here that they executed and created another container, but this time they passed an argument host name. So after giving the command docker run container name, and then they are passing an argument as host name. So this host name is getting printed in the output, and this is happening because this host name argument is basically overriding this particular argument which we have passed in our Docker file. So that is how a cmd keyword behaves, which means that any argument that you are passing in the cmd keyword, it will get overridden by the argument that you are passing in the docker run command. But when it comes to the entry point keyword, then as you can see that in the Docker file they are using the same command echo and then they are passing the argument. But if you come down and see here, when they are creating the container, they are passing an argument which is called knowledge base, right? This is a string item which they are passing when they are creating the container. But if you notice carefully here in the output, it gives the output hello world and then it prints the argument which we have passed in the docker run command, which means that in the entry point keyword, the argument that you are passing in the docker run command will not override the argument that we have passed in the Docker file. So the argument that is available in the Docker file, that will also get executed. Along with that, the argument that we are passing in the docker run command, that will also get printed in the output. So this is the main difference between the cmd keyword and the entry point keyword. So whenever you want your instruction to be executed irrespective of the arguments that you are passing in your docker run command, you should go with the entry point keyword. But if you have an instruction where you want to override the argument that you have written in your cmd instruction, then you can go with the cmd keyword. So that is the difference between the cmd keyword and the entry point keyword. So I hope that this is clear. So the last instruction that we have in this particular docker file is env and then the name of the environment variable. So basically the env keyword stands for environment variable, and as you can see that the variable name is name and the value is DevOps. So which means that this is the particular environment variable that we would want to be created in our container environment. So which means that you can also define certain environment variables inside your container environment. So this is going to be very useful when you are creating a container where you need certain environment variables to be declared firsthand when you create the container. So yes, so using Dockerfile we can define environment variables as well. So now let us come out of this particular Docker file and see how we can build the custom image from this Docker file. So before creating the custom image from this Docker file, let us create an HTML file, as we have an instruction instruction where the HTML file from the current directory or any files from the current directory will move to the var www HTML folder in the container. So you will give the command vi index.html. So now we are inside this index.html file. So I have pasted an HTML content in this particular file. So as you can see, it says this is testing project for Dockerfile. So this is the text that we are going to show in our web page. So just to let you know, what we are doing here is the Apache basically looks for its default web page in the var www HTML folder in the container. Now, since we are going to automatically install an Apache service inside the container, it will look for its web page, the HTML web page inside the var www HTML folder. Now, as per our Dockerfile's instruction, any file that we have in our current directory from where we are creating this particular container, automatically all the files in that particular current directory of the Docker host will get copied to the var www HTML folder. So what we are doing is, in our Docker host, in the current directory from where we are going to create the container, we are basically creating an HTML file and giving a default web page look. So what will happen is, once the container is created, automatically this particular HTML file will get copied from the Docker host to the containers var www HTML folder. So then if we run Apache from the container, then the Apache will be able to fetch its web page content from that particular folder. So now we have made the modification in this HTML file. So now let's save it. So now our index.html file is saved with its updated content. So now we are prepared with all our setup. So now let us execute the command to build our custom image. So the command is docker build dot -t, and then we can give the name of our custom image, which is web image in this case. So as you can see that the image is getting built. So first the Ubuntu image is getting pulled from the public repository. Then as you can see that all the instructions are getting executed one by one. The apt update command is getting executed. Then the Apache 2 is getting installed. So all the instructions that we had in our Docker file is getting executed one by one. These are basically to record all the instructions that was available in the Docker file so that the custom image can be built. So now as you can see that the image has been built. So now if we execute the command docker images, then as you can see that web image has been created, which means our custom image is created from the Docker file. So now using this particular custom image, we can create our container. So first let us check whether any container is running with docker ps command, and also let us verify with docker ps-a command. So as you can see that none of the containers are running right now. So let us move forward. So we will execute the command docker run -it, and then we will give the name of the container with the -name tag. So let us give the name as web server, and then we can do the port forwarding with -p tag with 8080 port. So 80 is the container port, and then after the colon it is docker host port 80, and finally we can write -d, and in the last we can write the name of our custom image. So as you can see that a container has been created. So now let us get into the container by giving the command docker exec -it. Then we can pass the name of the container, which is web server, and finally we can write bash. So now we are inside the container. So now let us validate whether all the instructions got successfully executed or not by validating whether the Apache service exists or not, and also the index.html file that we created in the current directory of the Docker host actually got copied into the var www HTML folder or not. So let us validate all such instructions that we had in our Docker file. So if you remember, the first instruction in our Docker file was from Ubuntu, which means that Ubuntu image had to be pulled from the Docker public repository, and then the container which we created from the custom image should be of the Ubuntu operating system. So first let us validate that by executing the uname command, using which we usually check the operating system of our Linux platform. So if we execute the command uname -a, then as you can see that Ubuntu has been installed as the operating system of the container. So now let us check whether the Apache 2 service is installed or not. So we can give the command service apache 2 status. So as you can see that the Apache 2 is up and running. So finally let us check whether the index.html got copied into the var www HTML folder or not. So we can give the command ls var www HTML. So as you can see that index.html is available in our var www HTML folder, which means that particular instruction also got executed from the Docker file. So as you can see that inside the containers environment, all the instructions got executed and corresponding operations are performed. Now also let us validate the index.html to see whether the content of the HTML file matches the content that we prepared. So here we added the content that this is testing project for Docker, and the same text is available inside the index.html, which means the same index.html file got created inside the container in the var www HTML folder. And our last instruction was to set the environment variable inside the container. If you remember, in the Docker file, which was with the env keyword. So if we execute the command echo name, then as you can see that the value is DevOps. If you remember that the name of the environment variable was name and the value of that environment variable in our Docker file was DevOps. So here, as you can see inside the container, when we execute the command echo $name, it gives us the value of our environment variable, which is DevOps. So I hope that it is clear how we can create a Docker file, how we can write all the instructions, how we can build an image from the Docker file, and also how we can create containers from a custom image. So this was to just give you a basic idea of how to create a Docker file, and we also discussed some of the keywords which we can use in the Docker file. But I also want you to know that there are many different possibilities and there are many different kind of keywords that you can use to perform various kind of operations in a particular container. So if you want, you can refer the Docker documentation and you can find all those instructions. But as far as this training module is concerned, we just discussed the basic creation of a Docker file and how we can build an image from the Docker file, and also how we can create a container from the custom image. So now let us move on and explore about Docker networks. So first we will see how we can create a link between two containers so that we are able to ping one container from another container. And this we will do by using the link command. But I want you to know that this particular command with the keyword link is deprecated or is going to be deprecated in Docker. So it is not recommended for use. But yes, this is something that you should know, that this is how links were created earlier between containers. After showing you or familiarizing you with this particular command, we will go ahead and create a bridge network, and then we will link multiple containers. So let us first create the container. So I have prepared the command already. So as you can see that the container 1 has been created. Now let me copy paste the second command where we will create the container 3, but we will link it to the container 1. So as you can see, this is the command using which we can link two containers. So now let me quickly explain you what's going on in this command. So first of all, if you notice that it is basically the same command that we are using to create any particular container. So similarly, we are using the same docker run command where we are giving docker run, then -it, and then we are declaring the name of the container, which is container 3, and we are using an extra tag here, which is -link. Now this particular tag, it will simply link the container which we are going to create with the container which is already created, which is already available. So if you execute this command, then automatically you will be able to ping container 1 from container 3. So now let us first execute this particular command, and after that we will get into the container and see whether we are able to ping the other container or not. So as you can see that the container has been created. So now let us get into the container 1. So we will give the command docker exec -it, and then we will say container 1, which is the name of the container, and finally we will give bash. So now we are inside container 1. So first let us open the etc host file. So we'll say cat etc/host. So as you can see here that we have a new entry in the end, which is nothing but of the container 3 that we have created. Since we have linked both the containers, then you can see that the IP and the hostname of the container 3 is basically given in this particular etc host file. So now let us execute the apt update command to just update all the softwares in this particular container. So as you can see that the apt update is completed now, and now let us install the ping package. So we can give the command apt install ping. So the ping package also has been installed. So as you can see that the output is complaining about a dependent package which is init-utils ping. So we will install that also. So we can give the command apt install, and then we can copy paste the init-utils ping package also. So now if we execute the command, it will install this particular package also. So let us give y. So this dependent package is also now installed. So as we have installed the ping, now let us come out of the container. So we can give exit. So now we are outside of the container and we are in the Docker host now. So now let us get into the container 3 with docker exec command. So now we are inside container 3. So let us perform the same actions here. First we will update all the software packages by apt update command. So let it install all the latest packages. So the update is complete. Now let us install the ping package again here in this container. You can give the command apt install ping. So as you can see, again it is throwing the same complaint here. So we will install the dependent packages also. Let us copy paste the dependent package. So the dependent package has been installed. So now ping should be working in this particular container. So now let us try to ping our container 1. So we can give ping container 1. So as you can see that we are able to ping container 1 from container 3. And this is happening because we have created a link between container 1 and container 3 in our docker run command itself. So which means that we have a connectivity established between these two containers. containers. But remember that this link command is going to get deprecated in Docker, so it is not recommended for use. But yes, this is something that using which we can create connectivity between two containers. And also in the etc host, as you can see, that entry of container 1 exists here from container 3 along with its container IP and container host name. So we are in container 3 right now, and let us do one thing. Let us try to ping container 3's IP from container 1. So we will copy the IP address of container 3, and now let us come out of this particular container 3, and now we will go into container 1. Let's see whether we are able to ping container 3 IP from container 1 or not. So if we do ping, and then if we give the IP address of container 3, then as you can see that we are able to ping both the containers from both the directions. So which means that using the link command in our Docker run, we can establish connectivity between any two containers. So I hope that this concept is clear. Now let us move towards creating the bridge network. So let us do everything from scratch. So first we will remove all the containers now. So first let us come out of the container 3, and then we will remove all the containers which are currently available. So we will give the command docker rm -f, and then we can write dollar, and then inside the bracket we can say docker ps -a and then -q, which will fetch all the existing containers. So there were two containers available, and both of them are deleted now. So they are forcefully removed. So now let us move on to create our bridge network. But before that, we will have to see what are the different networks we currently have. So we can give the command docker network, and then we can pass the instruction which is to list out all the networks, right? So we can give ls. So as you can see that we have few networks already available. So we have bridge network, host network, and one is none also. So we have three networks, and on top of these networks we will create our new bridge network, and using that bridge network we will try to link our containers. So I hope that you are getting used to all the commands that we have. So as you can see that we wanted to work on the network component of the Docker, right? So we gave the command docker network ls. Similarly, if you want to work on volumes or container or images or any other object in Docker, you can simply write docker, and then you can pass the component, and after that you can pass the instruction that you want to execute on that component. So it is as simple as that. So now let us move on. And also one more thing, you can always find help in all the Docker component commands. So if you give the command docker network -help, then as you can see that you have all the instructions that you can pass to that particular component is available in the help output. So you can see that you have commands like connect, you have create, you have disconnect, you have inspect, then you have ls, prune, rm, and all the functionality of these commands are also written here. So if we give the command docker network create, so we will be able to create our network. So let us give the command to create our network. So we can say docker network, then we can say create, and then we will write -d, which is to again run the network in detached mode. And finally we can give the type of network that we want to create, which is the bridge network. And in the end we can pass our name of our network, which in our case maybe we can say a small name myb, which basically stands for my bridge network. So we can just say myb. So as you can see that a new network has been created, which means a new network component has been created in the Docker engine. So now if we give docker networks ls, then as you can see that a new network has been added, which is myb. So using this network component we can create our containers and we can link them together. So this is the new way of creating any networking or bridge network in the Docker now. So now let us see how we can create containers and how we can link them using this particular new network that we have created. So in order to show this demo, I will use the play with Docker test lab. So here I have already created the network that we already created in the AWS account for demo purpose. So I have created that network. So if we execute the command docker network ls, then as you can see that I have already created the myb network here. So now what we are going to do is we will be importing or pulling an image from the public repository of a web application, which is actually written in the PHP code. And this web application will basically show a front-end form where we can give our name and we can store our data from the front-end form, and that will automatically go in the backend and it will store it in a DB. So basically we will create two containers. In one container we will have our web application, which we will pull from the public repository, and again in another container we will have our DB, and that DB will be the MySQL DB, and for that DB also we will pull the image from the public repository. So first we will pull both these images from the public repository, and then we will create containers, separate containers for both these images, and then we will link both these containers together in the bridge network. And later we will test where we will be inserting our data from the web application, and that data will go and store in the MySQL database in another container, which means both these containers will be linked together. So first let us try to pull the image from the public repository, and this particular web application and the MySQL image is in my public repository. So you also can pull both these images using the image name that I'm going to show. So both these images are available available in my public repository. So directly we can execute the docker run command and create the containers from it. And you can also follow along and use the same command, docker run -it. And then we can write the name of our container, which will be in the name tag. So we will give the name, for example, web, and then we can give the name of our network, which will be in the network tag. So we can write -- network, and now we can pass the name of our network, which will be MYB. And now we can do the port forwarding. So as I mentioned earlier, that this is a web application which can be accessed from the front end. So we will use the default port 80. So we will say -p, and then we can give 80, which will be the containers port, and then colon, and then the Docker host port. So we have mapped our Docker host 80 port to the containers 80 port, or we can say applications 80 port. And then we can say -d, which is to run the container in the detached mode. And finally, we can give the name of our image, which is available in the public repository. So you can also follow along and use the same name that I'm going to mention now. So the name will be my username. So this is my username, and then you can give /, and then you can give the name of the image, which is web app. So just follow exactly the same name, because if you do not give the same name, then you will get an error, which will be that your access to the repository is denied. So be a little more careful here and use the correct naming convention. So if you give enter now, so as you can see that a container has been created, and this is using the image which is available in the public repository. Actually, I already created this container earlier just to ensure that everything is working fine or not, or whether the image is getting actually pulled in this particular lab or not. So I already executed this particular command earlier, and that is the reason why you could see directly a container getting created. But in your case, because you will be pulling it for the first time, you will see that this image will first get downloaded into your server. And since I have executed this command just some time before, the image is already stored in the cache, right? So instructions are already available in the Docker engine. So that's why without installing or downloading the image from the public repository, it was able to directly create the container from the image. So now let us move on and create the second container, which will be from the MySQL image. So you can use the same command and just give MySQL in the end. And now we can remove our port forwarding because it is not required. So we can remove the -p tag completely, and we will change the name of our container. So as this is the database, so we will just give the name as DB. So you can also use the same command in order to create this particular container. So now if we press enter, so as you can see that another container has been created. So now if we give the docker ps command, so currently the DB container is running. Now let us see whether the web application container got created or not. So we can use the command docker ps -a. So the web application container seems to be running, but it is in the exit mode. So we can bring this particular container up by using the docker start command. So we'll say docker start, and then we will write the name of our container, which is web. So now if we see the docker ps command, then as you can see that both the containers are running, and also if you notice here that the port forwarding is applied for the web container. So we have prepared our setup to use this web application and validate our connection between these two containers using the bridge network. So now let us validate whether the web application is able to communicate with the database or not. So what we will do is we will try to create a record of an employee from the front end, and we will give the employee name and also the mobile number of the employee. So both these data should go from the front end, which is the web application, and it should go and store in the database. So in order to do that, we have to first create a table in our database. So I'm going to execute few commands. All you have to do is just follow along, because all these table names that we are going to use now are basically coded in the web application in PHP programming language. So don't give any other name, just follow along with me and execute these commands. So first we have to get into our DB container. So we'll give the command docker ps. So as you can see that the DB container is up and running. So we will get into that container. So we'll give the command docker exec -it, and then we will write the name of our container, which is DB, and finally we will give bash. So now we are inside the DB container. So let us first get into our MySQL database. So we can say MySQL, then we will write -u root, and then finally we will give the name, which is -pwihiz labs. So just give the same name, and then if you press enter, now we are inside our MySQL database. So first we will create a database. So now we are inside the MySQL environment. So first we will create a database. So let us give the command create database, and then the name of the database, which is company. So as you can see that we have created company database, and now let us give the command use company. Okay, so our MySQL environment is now pointing towards this particular database. Now we will create our table inside the database. So we can give the command create table, and since we are going to store the information about an employee, so let us name the table as employee itself, employee, and then first field is name, and we can store in varchar with maximum limit of 30 characters, and then then the second field will be mobile number, so we can say mobile, and then we can write varchar. Again, we will store in the character type, and then maximum limit will be 30 characters, and then we can close the bracket. So now if we execute this command, then as you can see that a table has been created with these two columns. So now if we execute select star from employee, then as you can see that currently we don't have any record in this particular table. So now let us move to our web container, and from there we will access the web application, and there in the web application we will create an entry for the employee by giving the name and the mobile number, and later we will see in the table whether that entry got stored in this employee table or not. So now let us try to access our web application. So here in this test lab you can see this button open port. So if you click this button, and then you can give the port number that you want to access. So you can simply give 80, since we have mapped our containers 80 port to our host 80 port. So here you can give the host 80 port, which is 80 in our case. So if you press OK, so I think the pop-up is blocked, so let me open it. Yeah, so now if we give open port and mention 80 here, so as you can see that the web application is open now. So here in this web page, we will give the name and also the mobile number. So in the employee name, I will just mention my own name. And then in the mobile number, you can just mention some dummy number. So any number you can mention, and then you can press add employee. So as you can see that we are getting record created successfully. So this particular success message is also coded in the PHP programming language in the application. So you don't have to worry about it. But now we will go to our database and see whether this record got created in the employee table or not. So as you can see here that the record got successfully created, which means that we were able to establish a connection between our web application and the database, where when we entered our information in the web application, we were able to store that data. We were able to fetch that data first, and then we were able to store it in our database. So this is possible only when there is a connection between these two containers. So this is how we can create multiple containers, and we can establish the connectivity between all these containers using the bridge network. So I hope that this is clear. Let us move on. So now let us move on and explore about Docker volumes. So if you remember in the part 1 of this training module, I explained a little bit about Docker volumes. So whenever you want to store any data which you would want to store out of the life cycle of the container, which means that the containers may be up, containers may be down, and it could be because you would want a container to be down, or you would remove a container, or you can have certain issues because of which a container may come down. So there are different reasons that life cycle of a particular container can get impacted, and we cannot rely on a container to store any form of critical data of our application or any other form of data. So in that case, it is always advisable to use Docker volumes. Now Docker volumes is a component which stores all the data outside of the lifecycle of the containers. So now let us see in Docker how we can create volume, how we can then create a container from that volume, and how we can store our data or the container's application data inside the Docker volume. So first let us see what are the different instructions that are available in the Docker volume command. So we can write Docker volume, and then we can write help. So if you see here, we have instruction that we can create a volume, then we can inspect a volume. So if you have created a volume, then you can execute the Docker inspect command on the volumes in order for you to understand all the parameters or configurations that are available in a Docker volume. And then you have the list command, then prune, which removes all the unused Docker volumes. So you can use this prune instruction in order to remove all the unused volumes in the Docker engine. And also you have the rm command, which is to remove one or more Docker volumes. So these are the various instructions that we can use in Docker volume component. So first we will create a Docker volume, and then we will create a container from that Docker volume. So let us first create a Docker volume. So in order to create, we can give the command Docker volume create, and then we can write the name of the Docker volume. So in this case, let us give the name as demo volume. So we'll just make it short. So as you can see here that the demo volume has been created. So now if we give the command Docker volume ls, so here as you can see that the demo volume has been created. So it is as simple as that. In order to create any volume, you have to just give the command doc volume create, and then the name of the volume that you want to create. So now let us try to create a container and map a specific path inside the container to this Docker volume, so that any new file or modification we do in that folder of the container, then automatically those changes will be reflected in this demo volume, or those changes or those files will be saved in the demo volume. So first let us create a container. So we can use the same command docker run. So we will say docker run -it. Then in order to map the demo volume to a destination folder of the container, we have to use the keyword mount, and then we have to write the source, which means the volume where we want to store our data from the container. So we can write source equals, and here we need to pass the name of the volume, which is demo volume. And then we can write the destination, which means the path inside the container from where we want to store all our data to this demo volume. So we can give destination equals, and let us say our destination path is app folder inside the container. And then all we have to do is we have to give -d, which is for detached mode. And then finally we can give the name of the image from which we want to create the container. So in this case, let us say Ubuntu. So now if we execute this command, then the Ubuntu image is getting downloaded from the public repository. So as you can see that the container has been created. So now if we execute the command docker ps, so the container has been successfully created and it is in up and running state. So let us move inside the container. So we can write the command docker exec -it, and then we can pass the container id, and finally we can write bash. So now we are inside the container. So if we do ls here, so as you can see here that an app folder has been created, and this is because we gave this app folder as the destination in our docker run command. And that is the reason why when the container got created, it got created along with the app folder. And this app folder will be the destination of the Docker volume, which means that any modifications or any new file we create inside this app folder, automatically it will be stored in the Docker volume. So now let us get into the app folder. So let me just create few dummy text files. So we can write touch 1.txt, maybe 2.txt, just few dummy text files. No content will be there inside as of now. So we'll just create these text files just to see whether these text files are getting stored in the Docker volume or not. So now if we give ls, then as you can see that we have these two text files. So let us come out of this container now. So we are out of this container and we are in the Docker host environment. And now I will go ahead and remove this container, which means that the text files that we created in the app folder will also get removed along with the container. So now let us remove this particular container. So we'll say docker rm -f, and then we can give the container id, which is here. Let us copy paste it. So the container has been removed. Now let us execute the docker ps command just to ensure that the container is removed. So we don't have any container in this Docker host now. So in order to validate whether those files are still present in that Docker volume or not, we will create another container, and this time we will set a different destination to see whether we are able to fetch those files from that Docker volume or not. So let us create another container now. So we'll use the same docker run command. Let us find it from the history. Yeah, so here we have that first command that we used to create the container. So now let us change the destination path. Earlier we had folder app, and now we will maybe change it to demo folder. So now if we press enter, then a new container has been created, but this time the destination is demo folder. So let us try to get inside this particular container with the docker exec command. So we can say docker exec -it, and then we can pass this id, and finally we can write bash. So now we are inside the container. Now let us see whether those text files are available in the demo folder or not. So if we give ls, so as you can see that we have the demo folder here. So now let us get into the demo folder and let us give ls. So as you can see that we have both these text files available in the demo folder, which means that if you map a particular Docker volume as a destination to any path inside your container, automatically all the files or all the folders which are there in that particular Docker volume will be fetched and stored in the destination folder of your container. So this is extremely powerful if you think about it. So we can basically store all our critical data that we have in our application in the Docker volume. So this also means that if you now make any changes in this particular destination folder, then those changes will also get stored in the Docker volume. And later, if you create any other container using the same Docker volume, then automatically the changes which you have done inside this container in this particular path will be reflecting in the destination folders of other containers as well. And this is basically happening because all these destination paths of different containers are linked to a single Docker volume. So this is how we can use the Docker volumes to store all the critical data in all our containers application. I hope that this concept is clear. So you can create n number of Docker volumes for different purposes, and you can link it to n number of destinations in your containers. Let us try to make a modification inside one of these files and see whether that modification or the modified content of the file is reflecting in the Docker volume or not. So we will try to make a modification in 1.txt. So we will say cat greater and we will give 1.txt. And now we can add some content, like for example, this is test content. So now if we come out of this particular file and then if we give cat 1.txt, .txt, then as you can see that this particular content has been added to this file. Now let us do one thing. We will come out of this particular container and then we will maybe create another container with a different destination, and let's see whether this particular content modification that we have made, is it reflecting in the new container's destination path or not. So first let us give exit. So we are out of the container now. So we'll give docker ps to see that our container is running or not. So it is in running state. So we'll just remove this particular container. So we'll say docker rm -f and then we will give the container ID. So this container has been removed. So if you see docker ps again, so we don't have any container. Now let us create another container by using the same command. So we will give a different destination path now. So earlier we had demo folder. Now let us give demo1 folder. So a new container is created now. If we give docker ps, then as you can see our container is up and running. So let us get inside this container. So we will say docker exec -it and then we will pass the container ID bash. So if we now do ls, then we should have the demo1 folder. So we have the demo1 folder. Now let us get inside demo1 folder, and now if we do ls, we have 1.txt and 2.txt. Now if we do cat on 1.txt, then as you can see, even the modifications that we are making inside the file, that is also getting reflected in all the destinations of all the containers to which you would have mapped your particular Docker volume. So I hope that these concepts are clear. This is going to be extremely important to plan how we are going to store the persistent data of all the applications that we are going to host in Docker containers. Here we saw that how we can create a Docker volume and then how we can map a particular Docker volume to a destination path of a container. We also explored that how the modifications which we are making in the destination path inside the container is automatically getting stored in the Docker volume, so that later when you create any new Docker container using the Docker volume, then those data are getting populated in the newly created container's destination path. So the next concept will be Docker Compose, but before that there is something that I want you to know, is that not only we can create Docker volumes and map it to our destination paths in containers, but we can also use certain folders which is available in the Docker host. So you can basically use the space or memory which is available in the Docker host also to store your container or application data. And we can do this by mounting a particular folder in your Docker host to the folder which you will be using inside the container. So let us see how we can achieve this. So I will create a container where I will map a particular folder in our Docker host to the folder or the destination folder inside our container. So first let us create a test folder. So right now we are in our root directory. So let us create a directory inside home. So inside home we will create a directory, say Ubuntu, and inside Ubuntu we will create a directory called mount. So if we go inside mount and then we will do pwd. Now for example, this is the folder where you would want all your application data to be stored in your Docker host, and this could be any kind of data, like for example all your application logs you would want to store in the Docker host directly, so that your container memory space is not being overused. Then in that case we can do that. So let us take this as an example where we will try to store all our application data or the container data from a destination folder inside the container to this particular folder in the Docker host. So now let us create a container. So we'll give the command docker run -it and then we have to write -v, and now we need to give the path of the Docker host where we want to mount the destination path of the container. So we will say home Ubuntu and then mount. So this is the source path in the Docker host where we want to store all our files from the container, and then we have to give a colon, and now after the colon we can mention our destination path inside the container. So let us give the same folder like we earlier did. We can say a demo folder and then -d to run the container in detached mode, and finally we can give the image. So now if we execute this command, then as you can see we have a container up and running. So if we go to docker ps output, then our container is running now. So let us get inside this particular container, docker exec -it, then we can give the container ID and then finally bash. So we created a demo folder as our destination folder or path. So now if we go inside demo and then if we create few files, like for example 1.txt, and we can also create 2.txt. So inside demo now we have these two files. Now let us come out of the container and go back to our source path in the Docker host, and I think we are in the source path only. So if we give ls here, then as you can see that we have those two files which we created in our destination path inside the container. So which means any application data that you will be storing in your demo path inside the container, automatically it will come and get stored in the source path of your Docker host. So let us do one thing. Let us remove that particular container. So if we give docker ps ls, and then we can give docker rm-f, and then we can pass the container id. So now the container has been removed. So let us execute docker ps to verify. Yes, the container has been removed. Now if we do ls again, then as you can see, our files are still retained in the docker host space or memory. So this is how we can store all the application data inside our container in docker host as well. So I hope that this is clear. So I'm concluding this video now to just keep the video length in control. So in this video we understood about three main concepts, which is how to create various custom images using Dockerfile, and then how we can create containers from those custom images. Then we looked at Docker networks, how we can create a bridge network, how basically we can create a link between two containers. And then finally we saw about Docker volumes, so how we can store our persistent data safely in a Docker volume, and also how we can store our data in the Docker host. So these were the topics that we elaborately understood in this particular video. In the next video, I will explain about Docker Compose and Docker Swarm, which will be the final two topics in this complete Docker training module. So see you in the next video. If you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos. Thank you and see you next time.